Hi everyone, welcome to today's presentation. Today we are going to look at a question on hydraulic press system. This question is on application of Pascal's principle, and the question reads, the figure below shows a hydraulic press system using a lever of negligible mass on the side of the small piston pivoted at point P. A force of 100 newtons is applied at R. So this is how the diagram looks like. And then part A, calculate the force F exerted by the small piston on the liquid. And then finally part B, find the weight of the bell supported by the piston on the liquid. So straight to the first part. Calculate the force F exerted by the small piston on the liquid. The first thing, we need to interpret this diagram. For us to determine force F, we are going to apply the principle of moments, and the principle of moments says that at equilibrium, the sum of clockwise moments should be equivalent to the sum of anti-clockwise moments. That is about the same point, like for this case, at P. So P is a pivot. Now we are going to determine the forces that will cause the clockwise moments and the ones that will cause the anti-clockwise moments. If we have P as the turning point, then force 100 will cause this beam here to turn in the anti-clockwise direction. So 100 newtons will cause anti-clockwise moment. And this force F, as it acts on the piston, then the piston will exert an equal and opposite force in that direction. And this is what we are considering at the moment. So we have this force here causing clockwise moment. So just like I'd said, considering the principle of moments, we'll say sum of clockwise moments should be equivalent to sum of anti-clockwise moments about point P. So for the clockwise moments, we will have this force F multiplied by the perpendicular distance, which is 50 centimeters. So we'll have force F times 50 centimeters. Let's have it in its SI unit, that is meters. 50 centimeters is 0.5 meters, and we will equate that to the one causing anti-clockwise moments. So 100 newtons causes anti-clockwise moments, and therefore we multiply 100 times the perpendicular distance from point R up to P. The distance is 150 centimeters. So we have that in meters. So we have force 100 times the distance 1.5 meters. Well, on the left hand side we have 0.5 F, on the right hand side we have 150, and that means dividing both sides by 0.5, the force becomes 300 newtons. Next, find the weight of the bell supported by the piston on the liquid. Now on this other side we have got the bell here, and it's supported by this piston. So we need the weight of the bell. The weight of the bell should be equivalent to the force that is generated on this piston. By Pascal's principle, pressure exerted at this particular point is transmitted equally to all the parts of the liquid, and that means the same pressure will be felt at this point. So we can therefore say pressure on the small piston should be equivalent to pressure on the large piston where we have the bell. So pressure on the small piston is given as force over area, and that is force on the small piston over the area of the small piston, and that should be equivalent to the force on the large piston, which is the weight of the bell, over the area of the large piston. So this is what we are going to use to solve this. Well, the force on the small piston, we've already obtained it as 300 newtons. So 300 newtons over the area. The area we already have as 50 square centimeters. It's not a big deal. We just use it the way it is without converting. So just have 50 and equate it to the force on the large piston, which will be the weight of the bell. That is what we are looking for, the weight of the bell. And then we have it all over area of the large piston. And area of the large piston we are given as 180 square centimeters. So over 180. Cross multiplying, the force on the large piston becomes 300 times 180 over 50. And when you work out this from my calculator, I'm able to get 1080 newtons. And finally, we have come to the end of the solution to this problem. Thank you for watching. See you in the next video.